this project, we explore the use of deep learning in virtual reality and how it may benefit patients who are undergoing physical therapy. Yes, physical therapy plays an essential role in helping patients to recover from injuries that limit their motor movements. However, the long rehabilitation process ranging from 6 months to half a year incur hefty bills for patients. Furthermore, not only do patients get bored of the repetitive exercises given, but they also run the risk of injuring themselves when they carry out the exercises at home without any proper supervision. In recent years, integrating virtual reality with physical rehabilitation has become increasingly popular. While it is effective and more engaging compared to traditional physical therapy, it only provides result-based feedback. Patients are assessed by whether did they complete the action and not how well they complete it. As a result, the effectiveness of integrating virtual reality with physical rehabilitation is limited. With that in mind, this project utilized deep reinforcement learning to create a golf environment targeted at patients suffering from shoulder arthritis. The humanoid agent is given the task of imitating the patient's movement and provide active feedback to the patient eventually. Firstly, we use Make Human to generate a photorealistic humanoid avatar based on the patient's gender, age, ethnicity and proportions. Next we apply a preset rigging of 31 bones to the avatar. Then, the rigged humanoid avatar is uploaded into Mixamo and a golf swing animation is applied to it. Finally, we train the humanoid agent to imitate the trainer's golf swing animation with deep reinforcement learning using Unity's machine learning agents toolkit. In deep reinforcement learning, the agent is rewarded for actions that achieves the target outcomes and penalized if otherwise. The machine learning agent toolkit aids the implementation of deep reinforcement learning by communicating the observations obtained from the game environment with the Python API outside of Unity. The Python API interfaces with Python trainers that contains machine learning algorithms. Within the game environment, the information flow between the agent and trainer is facilitated by a master controller. The animator script obtains characteristics of the humanoid trainer such as velocity, position and rotation for each body part of the humanoid avatar at each frame. The characteristics are passed on to the master controller which calculates the difference between the trainer's and agent's rotation, angular momentum and center of mass. These are used by the agent component to compute the corresponding reward. After configuring the joints and defining the reward, the agent is trained using proximal policy optimization, which is a machine learning algorithm implemented by Unity's ML agent toolkit. At the start of training, the agent's limb is seen to be moving randomly across the screen. After 37 hours of training, we can see that the agent moves quite closely to the trainer. In the future, the system will be able to provide live feedback based on the difference between the input motion from the person and the ideal body movement for a specific exercise. This will allow the patient to continuously improve based on the feedback given in the virtual game environment. Thank you.